Hi everyone, welcome to our 5th episode. In this episode we're going to start writing our driver control code, and specifically we're going to start by writing code to control our base with the controller, and we're going to look at two different styles of code to do that. The first one is going to be tank drive, and then the second one is arcade drive, and you'll see that they're just different styles of how it's controlled by the controller. Some people prefer one, some people prefer the other, so we're going to look at both. And to do this, we're going to build on the code that we wrote in our last video where we controlled a couple of wheels with the controller. So we're just going to take that code and modify it now to control all 4 of our wheels using the joysticks on the controller in a way that makes sense. So the first one we're going to look at here is going to be tank drive control. And so let me show you how that works. By the way, here's my third camera setup. I'm now using my smartphone as a camera, and I don't have a tripod for it, so it's not the greatest setup, but it has better quality video, I think, although it is a little laggy. So the way tank drive works is you use both joysticks, the left and the right joystick, and you just use the up-down axis on each of them. And each joystick is connected to one side of your drive. So the left joystick controls the left side, and the right joystick controls the right side. And when you push the joystick forward, that side goes forward, so this would be left side forward. And when you pull it back, that side goes back, so this would be the right side back. And so the way that you drive straight is you push both sides forward, so both sides of your robot go forward. Down would be both back, and then you turn by going one in one direction and the other in the opposite direction. So this would be turning left, and that's turning right. And you can also do like these arcing turns where you just do one side at a time. So this would be like the right side going forward and the left side staying still. Okay? So, but anyway, the concept is that you want just left joystick controls the left motors, and the right joystick controls the right motors. So now let's look at how we'll do that in our code. So this function down here, this command, was where we controlled the motor using our one of the buttons. And so that's not what we want to do. We want to control the motor using the joystick axis, which was what this first command here does. So basically what I'm saying is we don't want to look at that anymore. We want to use this kind of thing where we use the joystick axis. So we want the joystick get analog function. And so our left side of the drive, once again, I forgot to check what ports the motors were in, so hopefully I can remember correctly. So I believe the left side is in ports 3 and 4. So we already have motor 3 set up, and now we're going to do motor 4 is going to get the same treatment, joystick get analog. And once more, we want controller 1, and axis 3 is the up-down axis on the left side of the joystick. And just to show you that, axis 3 is the one there on the left, and look, it actually focuses this week unlike last week. Yeah, so axis 3, up-down axis on the left. And so hopefully motors 3 and 4 are the left drive motors. Okay, and so let's just start with that and upload it to the robot, and we'll see what it does. So I need to build it, and then I need to plug the robot in. And then upload it. Okay, and then let's take a look here at what we get. Put the VexNet key back in the robot. We'll turn everything on for you here. Okay, and so I just wrote the code for the left axis, so axis 3 here. And the robot's connecting, there we go. So let's see. So the way I think of it, the side that's facing you right now is the front. So this is controlling the left side of the robot. And I haven't programmed the right side yet, so this does nothing. But what you do see is that when I move the left joystick here, both wheels turn. If I get myself out of the way, both wheels turn just like what we want to have happen. And they turn forwards when we push it up, and they turn backwards when we pull it down. So they're both turning in the same direction. So now let's add the right side. So we'll go back here, and so you can just keep adding motors on the next line. So we'll just go down one line and add the next motor. And this one, if I recall correctly, was in port 7 and port 8. And so we're going to keep using the same joystick get analog command. And now we want the first controller, but the right joystick axis, which is axis 2 for up down, semicolon, and then motor set. And then the motor in port 8 is the other one on that side of the robot. And see, I accidentally capitalized the E there, which is no good. It needs to be lowercase because these are case sensitive. And I'm not very good at typing while I talk. Apparently it's like scratching your head and rubbing your stomach or something. I don't know. Okay, so that's what we want. So now we have the 2 motors on the left side and the 2 motors on the right side. And obviously you would change these ports depending on what ports your motors are plugged into. But axis 3 is for the left joystick, axis 2 is for the right joystick. Okay, so let's build this code. And by the way, I'm using Control-Alt-B to build instead of opening up this little thingy, so that takes forever. And then I need to plug the robot back in to the computer. And then we upload it. And I didn't wait long enough after plugging it in. There we go. And then put the VexNet key back in. Okay, and let me switch to the camera. And let's see what we get now. So left side still works just like it did before. And now right side goes the wrong direction. So I'm pulling it down, but my right side is going backwards. And I push it up, and my right side going backwards, not the way I want. And so if I push both in the same direction, it'll turn, but what I actually want is for it to go straight when I do both in the same. So how do we fix that? So the problem is that both of these 2 motors here go in the opposite direction of what I want. So when I go up, they go backwards. When I go down, they go forwards. So we're going to put a negative sign in front of each of these commands. And this would be the same thing as doing like -1 times that. Or we can just do negative. So the opposite of whatever number joystick get analog gives us. So right now when we go up, it's giving us a positive value, but we put the negative in front of it, and then that turns it into a negative value, so it has the motor go in the opposite direction. And this is just specific to how I have my motors connected and how I have them wired. It's possible that depending on which way your motors are facing, that maybe you need to reverse some of these other ones instead, like possibly 4 and 8 could be reversed instead of 7 and 8. Or maybe none of them need to be reversed. But anyway, so basically you just need to find out which motors are going in the wrong direction and then put a negative sign in front of the joystick get command for those motors, and that'll reverse them. Okay, so let's build this again. and plug in the robot once more time. It'd be really great if I had one of those wireless programming cable things for this video. Okay, and then upload it. Great. And now let's go back to the video here. There. Okay, and now if we go both forward, the robot goes forwards, and if we go both back, the robot goes back. And when we go one up and one down, the robot turns. If we go the other way, the robot will turn the other way. Okay, and so that's what we want. So that's how you do a tank drive in Prose. And now let's look at how we can do an arcade drive. So actually I should probably explain how this works. So the idea with arcade drive is that you just use one of the joysticks, or I guess you could use two, but the idea is that you go up with a joystick and down to go straight, and you go to the left or right in order to turn. And so I guess you could go up and down with the left joystick and left or right with the right joystick, or you could go left or right with the left joystick. But anyway, point is that just one joystick up down controls straight, and one joystick left right controls turning. So let's figure out how we can write that code. So let's start with the going straight part. So let's say we want the left joystick, which is axis 3 for up down, to control how we go straight. So if I just set all of these motors, actually, set all of these motors to axis 3, and I still need these to be reversed because we've found out like the reversing is part of how the motors are connected, how they're attached to the robot. So they're always going to have to be reversed in order for them to work the way we want. But so if I set every motor to joystick axis 3, then when I push it forward, all of them will go forward, and when I pull it back, all of them will go back. And right now there's no ability to turn, but this should at least let us get the straight part working correctly. And so let's just verify that. And by the way, like, this is good practice when you're developing code to make sure that stuff works individually. It's called unit testing. And so you can troubleshoot small problems rather than big problems. And so if you know that everything works individually, it's easier to diagnose a problem when it does come up. So like if we'd written this whole code and then it didn't work, then it could be harder to figure out what part of the code was not working. Okay, and so let's see what we get here. Hopefully our robot drives straight. So when I pull this down, the robot goes backwards. When I push it forwards, it goes forwards. And so right now the robot can only drive straight, no matter what I do with any of these joysticks, because we haven't programmed anything else. But so that's good. So we got part of our code working, and that's obviously different than what we had before. And so now let's add the turning part. And so now let's say we want to use joystick axis 1. So I'll do the left right axis on the right joystick for turning. So when we want to turn, we need the wheels to go in opposite directions on each side. So like we need the left wheels to go one direction, and we need the right wheels to go the other direction. And if we want to turn right, we need the left wheels to go backwards. Sorry, we need the left wheels to go forwards, and we need the right wheels to go backwards. So let's just figure that part out. So we want to use axis 2 now. And so, like, to be clear, what I'm doing here is we're just going to do the turning, and then we're going to add back in the going straight part. So when I push the joystick to the right, I get positive values. So all the way to the right would be positive 127. So if I want the left joystick, or I want the left wheels to go forwards when we go to the right, then that's what I already have here. This would be forwards when we go to the right. And then these here are our two right wheels. And if we want them to go backwards when we go to the right, then we need to take off this reversing here, because we already saw that what we had there would make them go forwards with positive numbers. So now this, without the negative sign, will make them go backwards. Okay. And so basically how you have to think about that is just what do I need the motors to do in order to turn one way, and then if turning to the right, for example, works, then turning to the left will also work when you put the joystick in the other direction. Okay, I'm plugging in the robot. Let's build this code. Oops, impatient. And then upload it. Okay, and now let's see if turning works. Okay, and so I programmed axis 1 to do the turning. So let's see if that's what we get here. So when I go to the right, I should hopefully turn to the right, which would be clockwise. And when I go left, oh dear, what did I do wrong? Oh, I did axis 2 when I meant to say 1. So if we go up with 2, we should turn to the right. And if we go down with 2, we should turn to the left, which is counterclockwise. So there we go. That's working like we wanted, except I accidentally used the wrong number. And you watching the video probably knew that, and you're like, stupid Jacob, he's putting 2 and saying 1. So let's fix that. But otherwise, our code worked. And, oh gosh. Comma 1. See, I need to stop talking while I do this. Okay, so there we go. So now we have the correct axis. And that'll work the same way as the second axis did. So now, how can we add back in the going straight part? So what turns out works just fine is that we can just add 2 of these together. And the math for why that works is like slightly confusing in my opinion, and I'm not going to try and explain it while I also try and type this at the same time, because I will probably make a fool of myself. But one thing to note about this is that if we add these values together, then it's possible to get a number greater than 127. And we were told before that the largest number we could put in the motor set command was 127, but it turns out that if we give it a number greater than that, it will just treat it as if it were 127. So basically, if you put in 200, it's the same as putting in 127. It still works all right. It just won't make it go any faster, is the point. So here, by adding them together, we can get numbers greater than 127 and less than negative 127, but it's the same thing as if you just had 127. And when you add them together, again, like I said, the math is slightly complicated, but the idea is that we just take whatever amount of going forwardsness and whatever amount of turningness we have, and we add them together, and that either like compounds and it makes the side go faster, or it cancels out and makes it go slower. So like if I were to push up and to turn to the right, that would make the left side go especially fast forwards, and it would make the right side not really turn at all, because going up would make it want to go forwards, but going to the right would make the right side want to go backwards, and so it cancels out if it's perfect and would not move at all. Or if we're like going more to the right than we're going up, then it would go a little bit backwards and a little bit forwards if vice versa. So anyway, the point is just add your forwards bits here on the left and your backward or your turning bits here on the right, and then you'll get your arcade control. So let's build this, and let me grab the robot and we'll test it one more time. Okay, upload that. Okay, beautiful. And let me show you the camera. Okay, great. And so now the left joystick, axis 3, up down should be going forwards. No, I did it wrong again. Oh, see, here's the problem. So it should be going forwards, but it's actually turning. And it's because I forgot that we had to reverse the right side in our code back when we had the forwards part. So let me fix that real quick. So these two earlier had negative signs in front of them, and I forgot to put that back in when I retyped these. Definitely blame that on the fact that I was trying to explain the 127 thing, although it really is probably just because I'm not that competent. Okay, so build it, upload it. Okay. See, so if anyone's like discouraged by programming, you can just take comfort in the fact that I make probably more mistakes than you're making right now in these videos. So, yeah. Also, maybe like you can learn from the fact that I troubleshoot things. I don't know. Okay, so now backwards is backwards, up is forwards with the left, and now left and right on the right joystick should allow us to turn. And it does. And so this is turning to the left, which is counterclockwise, and to the right is clockwise. And once again, this part of the robot here, where the VexNet key and the battery are, is supposed to be the front. So that's the left, the right, backwards, forwards. And so if I do both at the same time, like forwards and to the right, you see I can kind of get the same arcing turns that are possible with Tank Drive. Okay, so that's an arcade drive in Prose. In the next video, we're going to program the rest of our driver control routine, which will involve our lift and our intake.